Hello, and welcome to a little video about Target 6A, Formal Reasoning in Euclidean Geometry. First, let's start by going over how we properly name angles and line segments. Number one, we use three capital letters that represent the vertex and 1 point on each ray. Make sure that the vertex is the letter written in the middle. The vertex is that little pointy part of our angle. The second way to properly name an angle is by only using the letter, or the vertex, sorry. I was going to say the middle letter, but I gave myself only one space. Vertex. Or number three, using the letter or number on the interior of the angle. Alright, so I know there's only three proper ways, but we can actually name our angles in four ways, because the first way can go in two directions. Let's check it out. Letter A. Here's the first way, and this is where we use three letters. We can call it angle N, M, L, or we can call it L, M, N. We want to make sure that this M, this vertex, is in the middle. Next, we could just use the vertex, angle M. And the last way is the interior angle, which is 6 on the inside, angle 6. Sweet, let's try letter B. The first two ways are angle CBA and angle ABC. The second way is just to label it angle B, and the third way is angle 3, because the 3 is in that interior part. Letter C. We can name it angle PQR or angle RQP. We can just name it angle Q, and we could also name it angle 2. In letter D, we can call this angle FGH or HGF, as long as G is in the middle. We can also just call it G or angle 1, because that's what's in the interior. In E, F, and G, let's circle the different ways to properly name each angle. Okay, so this angle, we can call it A, B, C. Do we have that? Sweet. We can also have CBA. Do I have that? No. Okay. The next way is I can call it by the vertex, which is B, angle B. And I can also call it by the interior, angle 1. For letter F, same thing. I can call it DEF. Okay, I have it. I can call it FED. And I can also call it angle 2. I can call it angle E, but I can't call it angle F. For this last one, I can call it LMN. Do I have that? No. I can call it NML. Do I have that? Yes. I can also call this angle M. Don't have that. Or I can call it angle 3. Sweet. Now we also need to go over how to name line segments. A line segment is a straight line with two, I forgot what I was going to write for a second, endpoints. That means it starts and it stops. How do we name the line segment? Use the letters. Oh yeah. Letters representing the two endpoints, and add a line. What? A line over the two letters. Cool. Let's name the line segment. Here we have letters X, Y, with a line on top. PQ with a line on top. CD with a line on top. Ooh, there's a few here. I have GI, I have GH, and we also have HI. We can split this into 3 little line segments. Ooh, letter E has several. All right, let's go. We got AP, we got AM, and AB. We got PM and PB, and of course, MB, M to the B, M to the B. All right, so now that we've reviewed that real quick, let's get started on the actual unit. The first thing that I want to talk about is the linear pair postulate. This is if 2 angles form a linear pair, then the angles are supplementary. So that means supplementary is they add to 180. So in number 1, if ABC forms a linear pair with CBD, let's use the postulate to determine its value. All right, so we got 5x plus x plus 30, because that's ABC, plus CBD, and together they're supplementary, so they add up to 180. All right, let's do some algebra. Okay, the first thing that I'm going to do is combine like terms. So I'm going to combine 5x and x, and I get 6x plus 30 equals 180. Next, I'm going to go ahead and subtract 30 from both sides. So now I have 6x equals 150. And of course I can finish this up by dividing both sides by 6. X equals 25. Number 2, same idea. If ABC forms a linear pair with CBD, let's find the value of x using the linear pair postulate. All right, let's do it. We got 5x plus 4x plus 18 equals 180. That's ABC plus CBD, and they're supplementary. Oh, actually, I think we could say, what if we do linear pair postulate equals 180? Linear, ooh, I like that color coded. Anyways, let's do some solving. First, I'm going to combine like terms. 5x and 4x become 9x. Everything else stays the same. Next, I'm going to go ahead and subtract 18 from both sides. 9x equals 162. Right? Right. And then, of course, finish by dividing both sides by 9. And I have that x equals oh man, I thought I'm having a brain fart. I need to do this on my calculator. Oh, 18. I was doing it right. Okay. Life is good. X equals 18. Okay. The next 2 things I want to talk about are the words congruent and then, of course, the vertical angle theorem. So congruent is a word I'm going to be using a lot, and you're going to hear it a lot this unit. You're going to hear it so much you might get sick of it, but that's too bad. So congruent is when 2 objects are identical. In the case of angles, it means they have the same measurement. Or if we have line segments, they also have the same length. And we denote them with this equal sign with a squiggly on top. We also have a vertical angle theorem that states that the opposing angles of 2 intersecting lines must be congruent. That means angles that are crossed from each other when 2 lines are crossing are identical. So in this picture, angle 1 and angle 3 are vertical angles. They have the same measurement. Let's take a look at these postulates and see which property they fall under. Okay, In letter A, we have GFH. Let's highlight it. GFH. GFH. I'm going to mark it like this. And KFH. KFH. I'm going to denote it with 2 because it's a different angle. Are supplementary. That means they add up to 180. So this is the linear pair postulate. In letter B, instead of having angles, we have little line segments. It looks like it didn't print with my little hats on top. Let's put the little hats. So what this is saying is RS plus ST equals RT. Let's kind of color that in. RS plus ST equals, oh man, RT. So this whole length. Well, that's us doing some addition with segments. You know what this is going to be called? Segment addition. I know, very creative. Letter C is kind of similar. Here we have the measure of angle WXZ. Let's mark it. WXZ. And if we combine it with measure of XYZ, or ZXY, my bad, ZXY, that's this angle. If we do that, then we get angle WXY. WXY. Well, if we add 2 angles, they become a bigger angle. You know what this is going to be called? Yeah, angle addition. Oh, postulate. Postulate. All right, last one, letter D. It says that GFJ is congruent to, that means equals to, the same measurement as HFK. I can mark it with the same one. This is the vertical angle theorem. Sweet. In number 4, let's just do a little bit of algebra and name the postulate we use to solve. In letter A, I see a flat line and I see 2 pieces of angle, or 2 angles that make it up. Well, a flat line has 180 degrees, and if 2 angles make up 180 degrees, this is the linear pair postulate. Let's do some adding. If we use this linear pair postulate, that means we can add the right angle and the left angle together to equal 180. So x plus 118. Well, this is a one-step equation, so let's go ahead and subtract 118 from both sides. X equals 62. Letter B. I have 2 angles across from each other. This is the vertical angle theorem. This theorem states that we can set these 2 angles equal to each other because when 2 lines cross, the angles that form across from each other are equal to each other. Well, that's how I say it in my words. That's obviously not the official one. Okay, let's solve it. Nice little 2-step problem. Let's add 19 to both sides. So we got 35 plus 19 is a 54. And then we're just going to divide both sides by 9. Oh, I wrote too big. That's okay. Because x still equals 6 and I had room. Fantastic. If you have, I think that's it for A. Fantastic it is. If you have any questions, please let me know or whoever else is helping you out with this. Have a wonderful rest of whatever day it is for you. Bye!